Hello, good day viewers. In this tutorial, we are going to integrate the function tan³ of x divided by cosine³ of x with respect to x. All right, let's get started. First of all, I would like to transform tangent in terms of sine and cosine. You know, tangent is the same thing as sine divided by cosine. So this is equal to the integral of sine cubed, because this has a power of 3 of x, divided by cosine cube of x. This is the same thing as tangent cube of x, but remember to divide by this one as well. So we divide by cos cubed of x with respect to x, and this cos cube of x will drop down to multiply this other cos cube of x. So this is equal to the integral of sine cubed of x divided by cosine 6 of x. According to one of the laws of indices, if you multiply them, it's like adding the two exponents together, dx. And also, I would like to transform sine cube of x as sine squared x multiplied by sine x. It means the same thing. So this is the integral of sine squared x multiplied by sine x divided by cos 6 of x with respect to x. One thing you should remember is that sine squared x plus cosine squared x is equal to 1. If this is true, sine squared x is equal to 1 minus cosine squared x. Therefore, instead of this sine squared x, we can write it as 1 minus cosine squared x. So this is equal to the integral of 1 minus cosine squared x multiplied by sine x divided by cos 6 of x with respect to x. And from here, we are going to start substitution. Let u be equal to cos x. Differentiate both sides, you have du equal to, differentiate cos x, you have negative sine x, then dx. Multiply both sides by -1, you have negative du equal to positive sine x dx. So what we need to back substitute is this and this. All right, to the top you can see we have sine x dx, and we have sine x dx here. Therefore, we can substitute it with negative du. And wherever we have cosine, we are going to replace it with u. So to the top, we have 1 minus u squared, because cosine is equal to u from here. And sine x dx is going to be replaced with negative du. So to the top, we have 1 minus u squared to the top, divide by, to the bottom, we have cos 6 of u, which is u to the 6th power, right? Then the other one is negative du. So we can bring the negative sign outside and the u remain inside. All right. Now let us split the fraction. This is equal to negative the integral of 1 divided by u to the 6th power minus u squared divided by u to the 6th power du. This is equal to negative the integral of u to the -6 minus, and you know that you can simplify this according to one of the laws of indices. You take a base, which is u, then 2 minus 6 is going to give us -4, right? So we have -4 here, du. So now let us integrate these two terms separately. This is equal to negative. If you add 1 to this power, it becomes -5, and you have to divide by that -5. So we have u to the -5 divided by -5, then minus, if you add 1 here, it becomes -3. So we have u to the -3, but you have to divide by that -3. We are moving. This is equal to negative multiplied by, you can say that this is -1 divided by 5 multiplied by 1 divided by u to the 5th power. Then we have minus minus is plus, 1 divided by 3 multiplied by 1 divided by u to the third power. If you drop the u's, the exponents will become positive, right? And if you distribute this negative sign, all other signs will change. So this is equal to positive 1 divided by 5 multiplied by 1 divided by u to the fifth power. You know that u is cosine, right? So we have cosine fifth of x. Then this negative sign multiplied by positive sign, we have negative sign. We have 1 divided by 3 multiplied by 1 divided by u to the third power, which is cosine to the third power. Don't forget to add the constant of integration. As we are moving, we know that 1 divided by cosine is the same thing as secant. So this is 1 divided by 5 secant fifth of x minus 1 divided by 3 multiplied by secant third of x, then plus the constant of integration, and we are done. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.